Students, welcome back to the second part of lecture number 6. So, let us focus on this slide first, whatever I discussed. So, basically I differentiated between the concept of joint probability and the conditional probability. Joint probability is a probability of two or more simultaneous events, often described in terms of events, let us say A and B, which can happen. Okay. And this is very easy, that joint probability is always written as probability of A union B, right. So, I have shown you board also that you have two events A and B are appearing, and then intersection is given by this part of this Venn diagram. So, that is what is called A intersection B. Probability of intersection B is what is known as a joint probability. Conditional probability is a probability of one event happening given that other event has already occurred. It is always described as P A slash B, probability of event A when B has already occurred. That is what is the meaning of this. Now, if I write other way, probability of B A when A, probability of B when A has already occurred, right. So, this one is probability of A when B has occurred or happened. This is probability of B when A has happened. So, this is what is called conditional probability, and by using certain sets of mathematical equations, I showed you that conditional probability of A when B has occurred is related to conditional probability of B when A has occurred by this fundamental equation. That means, one probability if I know, I can calculate the other probability. That is the advantage. Okay. So, conditional probability, let us say conditional probability of event A. By the way, this one P A slash B and P B slash A, they have some names. This is known as a posterior probability in machine learning. Of any event A, and this is known as, oh, by the way, this and this are also important. This is known as a conditional likelihood, P B slash A. That is what is called conditional likelihood, and P E or P A is the marginal probability. And P B is called prior probability. Okay. This is the way we define these four different terms: posterior probability, conditional likelihood, marginal probability and prior probability. This is how we define different terms. So, now let us say if I have to write posterior probability of A slash B, thus for a given value of event E, given value of event, this is something like I am tossing a coin. What is the given probability of getting 10 rupees? Okay. Top side of 10 rupees coin, that is what is called E. So, this can be easily written as like this. So, P B slash A and multiplied by P P, what is that? Yeah, PAB, right? PA, no, yeah, PA, that is equal to E divided by PB. That is what is the equation is, right? And yeah, this will it will look like this. Okay. Just for a particular event E, or event is a value E. Okay. So, if there are k events, this, the next one is more important. If there are k events, let us say k simultaneously event occurring, and where k is represented as 1, 2, 3 dot k, many as k, then we can write down by B as like this: probability of what? Probability of B slash AK into probability of A, sorry, AK, not A, divided by probability of B. This you want to, if you want to expand, this will look like probability of B slash AK, remove this, multiplied by probability of AK divided by summation of probability of AK into probability of B by AK, sorry, B by AK. So, what you are doing? This is nothing but summing over all the probabilities at the denominator. You can see there, that is what is known as that is how we can calculate the posterior probability of multiple events. Here k can go to 1, 2, 3 to k, any number. Okay. This equation is very important, because this provides you, if you have many data, how to calculate the posterior probability very easily. So, let me come over here and explain you by an example. Okay. Let us say this is the example. Let us say consider a fictional data set that describe whether conditions for playing a game like golf, given the condition, each tuple classified condition as yes or no for playing golf. So, I have outlook 0, 1, 2 to 13, and that means 14 2 weeks data, and so I have temperature, humidity, wind, and then I decided to play golf or not. So, I have rainy, overcast, sunny. These are 3 different temperature conditions, excuse me. So, I have rainy, overcast and sunny, 3 different temperature conditions. Okay. Then you have humidity, which is consists of hot, mild, cold, these 3 concepts. You must be wondering whether temperature or humidity are interchanged. No, this is same. And then wind can be high, normal, right. There are 2 kinds of winds, high and normal, and you have either false means we do not play golf, no, and true means okay, yes, but still you do not play golf, okay, target is no. So, this is what is that your table is showing. So, now what we do? We make several many other tables. Let us say this first one I explained clearly to you. We have outlook, sunny, overcast, rainy. So, you can see there are 2 outlook, sunny where we play tennis, right, sunny, yes, sunny, yes, right. You can see these 2, this is the one, this is the one. And similarly overcast, how many are there? So, let me first erase out that, otherwise it will be messing up. Overcast 1, yes, and another one is yes, 2, Is there any other overcast or overcast situations? Overcast, yes. Overcast, yes. There are 4, right? You can clearly see 1, 2, 3, 4. That is what it is called 4. It is yes. So, I erase this part. I hope you understand that for sunny there are 2 days in which it is yes. For overcast it is 4 days it is yes. So, now let us see what happened to other condition like rainy. Rainy is, what is the other condition? What is rainy, right? How many yes are there? Rainy? No, no, no. Yes, here there is a yes. Rainy, where is rainy? Yeah, there is a yes here, and then there is a yes there. There are 2 yes, right? Now 3 yes should be there. Rainy, rainy, yes, rainy, yes. No, no, no. Where is 3? There should be 3 yes. That's what they are saying. Rainy, no, rainy, no. Overcast, rainy, no, rainy, yes, rainy, yes. So there is something wrong. I mistake I made. So it should be 2 then. So then it should be 8, right? Okay, that's great. I've corrected it. So as you can see, there are rainy. There are 2 yes. I can see. Sunny, there are 1 yes. There are another yes. Oh, sunny, there are 3 yes. That is correct. That's why it is 9 is okay. So that means this is the updated table. This is correct. I made some mistake, but I am now corrected. Sunny is 3, okay. Overcast 4 and any 2. You can calculate sunny is ES1, ES2, and then you have a sunny also ES3. So 9. And similarly, no for sunny is yes, which you can find out easily. Sunny, no. Sunny, no. And there must be another sunny, no, right? Rainy. Okay. So, you can calculate probability of this posterior, this is not posterior, this is basically marginal probability, that is for sunny is 2 by 9 for yes, 3 by 5 for the no. Overcast is 4 by 9 for yes, 0 by 5 for no. Rainy 2 by 9, 2 by 9 for yes, and 2 by 5 for 0, and total is obviously 100%, right. This is for outlook. Temperature, obviously I think that is what I said you, there is a mistake in the table. Temperature can be hot, mild, cold. So, you can also do the same thing, yes, no, yes, no. So, you can clearly see probability yes, probability no. Humidity also high and normal, you can do the same thing, wind also false and true. So, that means basically this is wrong, this is pay golf. Table has been changed because of the change of PowerPoint. So, this is windy, this is not windy, this is humidity, this is your temperature, this is your outlook. Okay, I am sorry about it, please check about it. This is your days. Fine. So, that we can easily change. This is your target, this is your humidity, okay, still not clear. This is your wind. Let me write it properly, because this is important. If the table is not correct, everything else will not be understood. So, this is days, this is temperature, no, this is not temperature, this is outlook, how the weather look like. This is your temperature, this is humidity, wind. Okay. So, let us talk about the temperature since for the sake of completeness. If I look at the temperature, temperature can be hot, mild or cold. So, let us hot. How many hot days are there for which you have yes? How many hot days are there? Hot, hot, yes. There is one yes here. There is one yes there I could see. Where? Hot, yes, here. One yes. Is a yes, there is another yes, hot. So, hot 2 you can see. Mild, how many yes is there? Mild yes is 1, use different color. Okay. Mild yes, mild yes, mild yes, mild, there will be 4 mild yes. So, this is also yes. So, mild yes 1, mild yes 2, mild yes 3, mild yes 4, yes. You can yourself calculate from this table. So, you can see 3, cool there will be 3, total is 9 and exactly for the no also 2, 2, 1 that is 5. So, therefore, probability of PS is 2 by 9, 4 by 9, 3 by 9, probability no is 2 by 5, 2 by 5, 1 by 5. Let me do it for the wind, basically false and true. So, false yes is 1, you can see here there are 6 it says, false yes is 2, false yes is 3, false yes is 4, false yes is 5, false yes is 6, that is why it is called 6, right. And now true 3, let us start true, true yes 1, true yes 2, true yes 3, right 3, it will become 9. So, no is again very easy, false no 1, you can see here, and false no another one 2, that is why it is 2, and true no 3, you can see true no 1, this is 1, right, and true no 2 and true no 3, okay. That is how we can calculate, that is what I am saying. So, that theorem allows us to distribute this data into these different features, outlook, temperature, humidity and wind. Now, we can always determine whether is you are going to play tennis or not. You can see here what we done in the last table is basically play yes 9, play no 5, total is 14 because there are 14 days. So, P is given 9 14, 5 F 14. We can actually calculate this using combination of these probabilities, that is the advantage. Okay. So, let me go to the next example. Okay. So, let us do that. That is for the metallurgy or material science. This is taken part from the book of Zhang, and here we are showing 18 high entropy alloys collected from Young et al. All these alloys either show single phase FCC or FCC plus BCC. They are processed with two conditions, one is air cooled or mechanical alloying. Okay. You can see here, and we know that features which are important to decide the high entropy formations are balanced selection condition concentration, electronic differences and obviously processing conditions. These are the three conditions which are important. This is your data, these are the alloy chemistry, this is your processing conditions, balanced selection conditions, delta and phases, all given to you. VC is calculated by Samit et al. Balanced selection concentration is calculated by this formula. Okay. And so, therefore, so this is VC, this is delta, that is what delta is calculated by this formula by basically atomic size differences. So, now what we can do? We can calculate these different parameters simply by from this table. What will parameters we can calculate? Let us talk about it little more detail. Okay. So, first of all we can calculate. So, as you can clearly see, if you talking about FCC, N1 is 10. Let us say first one is used for testing, we don't touch it, rest is used for training. So, how many 10 are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, N1 is 10 and N2 1, 2, 3, 5, 6, 7. right. So, therefore, I can write down probability of y is equal to one phase is 10 by 17, probability of y is two phase is 7 by 17. Is it correct? This is very easy, right. This is the total number of events is 17 and for the single phase FCC is 10. So, therefore, 10 by 17. Problem event is here is 7. So, total number of events 17. So, therefore, two phase is 7 by 17. Now, we can also calculate N11. If you carefully know N11, that is single phase processed by AC, okay, is basically 7. Yeah, can you do that? Can you find out that? Let us say FCC AC is what? 1, 2, 3, 4, 5, 6, 7. Clearly see that? The first one you use for testing, therefore, we are not touching. So, N11 become 7 and 12 become how many? Two pages. So, MA 1, 2, 3, 4, 5, right? N21 is 2, sorry, N21 is 1, 2 is 2, right? Obviously, 1 is single phase and prepared by MA, there are only 2, right? 1, 2. MA is 1, 2. No, it is not 1, 2. How many are there? Let us see. MA single phase 1, 2, 3. 3 are there, right. So, therefore, if I have to calculate P y, P x is AC and y is 1, that becomes what? That means x means what? It is air AC is the processing conditions by which is produced as cast. AC stands for as cast. Let me write down. MA stands for mechanical alloy. So, then it becomes what? It becomes 7 by 10. 7 plus 3 is 10 and 7 by 10. Similarly, P x is equal to M A, y is equal to 1, that is equal to 3 by 10. So, this is what is your posterior probability, right. You can easily calculate this way. So, not only that, you can even find out the standard deviations. How do you find out standard deviations? Let us talk about x bar, okay. That is a standard deviation. So, you can easily find out that is total event is 10, 1 by n is 10, sum it over n is equal to 1 to 10 x 1 x AC basically 1 x and this is W2, that is nothing but how much? Yeah, that is basically you will get 8.518 as per these calculations. So, as you have to sum it over all the x's and you have to calculate using this weight factor W2, right. So, similarly, you can calculate other the standard deviations and the mean actually. So, this is the mean, not standard deviation, this is the mean and the standard deviation will be calculated simply by that this is root over of 1 by 10 and sum it over again same thing, okay, x 1 W 2 minus x 2 square, that is what the standard deviation is. So, you can completely calculate all the probabilities, calculate the standard deviations, form such kind of tables and then you can even predict. These are the predictions by naive Bayes classifiers and you can see that measure class, predicted class they remain same except for this alloy. Measure and predicted class, measure is single phase, predicted is two phase and this class. These two predictions and measure values do not match. So, that means this algorithm is not cannot give 100% perfect answer, but it can actually. So, one can actually make a confusion matrix based on that. If you do not know confusion matrix, we can discuss later, but I am just telling you confusion matrix allows to calculate predicted class versus measure class. So, predicted class FCC and FCC plus BCC you can see here, and measure class is FCC and FCC plus BCC. This is how the confusion matrix is prepared, and from that you can calculate all these things. All these things means what? True, TP, NP, FN, okay, false, negative, true negative, true positive, everything you can calculate, right, and do that things. So, let us stop here, we will come back and maybe discuss even little more way on this confusion matrix case and tell you how it can be done. But nonetheless, I shown you that the base equations which allows you to calculate posterior probabilities can be directly used for data science here. And by simply using this equation, you can from the data you can calculate all the probabilities and find out the best possible predictions. Thank you.